So we finally made it here. We're going to learn how to predict products. This is the big part of chapter 8. Everything builds into this. I'd recommend before we get started here that you find your green sheet and your yellow sheet. I'm going to show you how to use the green sheet, and then we will be pulling in some oxidation numbers from your yellow sheet to help balance the formulas. So let's get started. The first thing I want to point out is that these are difficult at first. It will take some time. It takes practice like everything else in this chapter. You don't get better unless you just take a shot at a few. You struggle through the first couple, and then they start getting better. So some hints. And this is all on your green sheet actually. Salts. That's another word for ionic compounds. Basically, a salt is a compound that's a metal in a nonmetal or a metal in a polyatomic ion, which you probably recognize as being ionic compounds. So another word for them is salts. So in our, general public discourse, the word salt refers to table salt, which is sodium chloride, but any ionic compound is considered a salt in chemistry. Now an acid, acids start with H, so if you see a formula that starts with H, that does not include water. Water is H2O, technically it starts with an H, but we do not count that as an acid. But other formulas do. I'll show you some examples in a little bit. And then a base is a compound that ends in an OH. So you see a compound that ends in an OH, you should be thinking base. A hydrate is something that ends in a dot H2O. We talked about those earlier. We'll come back to those and use those here coming up. Now, here's a list of acids, of common acids that you've probably used in lab. Acetic acid is just vinegar, but notice they all end in H, 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 H. These are also on your yellow sheet. So, to predict products, what you're going to do is balance and give the type of reaction. So we'll go a little bit quicker here to get the main parts of this. We've got 1 calcium on each side, 2 nitrates on each side, 1 lead. This one's actually already balanced. Now the next thing I'd look at is I've got an element and a compound, and it looks like the calcium's replacing the lead. So that leads me to believe that this is a single replacement reaction. But we're going to take this one step further now and say, okay, what type of single replacement reaction? So take out your green sheet and you go, okay, here's my single replacement reactions. Now, which of these single replacement reactions am I working with? Because being able to be more specific here will help me in the next slide figure out how to predict products. So what I've got here is I've got a metal. Calcium's a metal. Now, for this one, you got to ask yourself, does it start with an H? The answer is no. Does it end in OH? No. Does it have a dot H2O? No. So that means it's just a metal and a polyatomic. It is a salt. So we've got a metal and a salt. So let's go here. Metal acid, metal salt. Perfect. Metal salt. That's an option. So that's the second option. So what I'm going to do is I'm going to say this is a SR number 2. So that's how I'll do that one. For this one, I've got 2 compounds combining to form, or sorry, 2 elements combining to form a compound. So that's a synthesis reaction. So let's head on over here. Now, we don't have a specific synthesis. It's a decomp, single replacement, double replacement. We have numbers for those 3, but we don't really have numbers for combustion or synthesis. There is one. Now, you don't have to put number 1 for combustion because there's only one option. So we're done there. No numbers are needed for synthesis. Now, for balancing, we're going to say, okay, this is 3 oxygens. I need to double it, triple this one so that there's 6 on each side. That gives me 4 aluminum, so I go 4 there. Now the bottom one, this is a combustion reaction because I've got CH. CH reacts with O2, CO2, H2O, combustion, and like I said, we don't need a number for this one. So we're good there. Now to balance it, I recommend always doing this one last on combustions. always do this oxygen last because there's two separate oxygens over here, and either of these numbers will affect this number, so it's best to do this one last. So what I always do is I say, okay, there's 2 carbons, we'll put a 2 there, there's 6 hydrogens, so I'll put a 3 here. This is actually a problem because this 3 here gives me an odd number of oxygens, and I can't have an odd number. So if that is ever a problem with a combustion reaction, go back and double the original, or the CH compound. Let's go and erase these now. If that ever happens, if you ever get an odd number here of oxygens, go back and just put a 2 in front of the CH compound. Now what this will have me do is put a 4 here, a 6 here. 4 times 2 is 8. 6 times 1 is 6. 6 plus 8 is 14. So I've got 14 oxygens on this side, so that means I need a 7 there. So the combustion tend to be the tougher ones to balance, but that's the trick to doing them. Now things get a little bit trickier here. Now you got to do the same thing, but you're only given the front half of the equation. So if you're looking at this, the first thing I'd recommend doing is identifying what you're working with here. You've got a compound plus an element. Now, does this start with an H? Yeah, it's an acid. Okay, now is this metal, non-metal, what is it? And magnesium is a metal. Metal. Oh, my writing pad's been very glitchy here, so it doesn't make curves very nicely. Okay, now I've got an element in a compound. This looks like a single replacement to me because I've got an element in a compound. I'm going to expect a new element in a new compound, and the magnesium's probably going to come in and kick out the hydrogen because magnesium likes to be positive, the hydrogen's positive oxidation number. So the magnesium will probably react with the chlorine, but we'll double check our green sheet just in case. So let's go single replacement, acid plus metal. Check your green sheet. Single replacement, metal plus acid, right there. We've got it. And it actually gives you this exact example, which that may happen on the test, but let's pretend like we don't see this right now. If you get this on the test, feel free to use it. But what it tells me is that it's going to form hydrogen plus a salt. Now, hydrogen is H2. Whoops. Okay, so it says it's going to form hydrogen, H2, plus a salt. Now, what will that salt be? The magnesium we know is going to come in and kick off the hydrogen. That's where we got this from. And remember, hydrogen is diatomic. That means that it's never found alone. It's always found as a pair with itself. And then what we've got is Mg with Cl. And we always write the positive oxidation number first and the second one, or the negative one second. Now, you might be tempted to just be like, okay, there's 1 Mg, 1 Cl, so Mg, Cl, I'm done. But you actually have to check the charges. Do the charges balance? And magnesium has a +2 oxidation number, and chlorine likes to form a -1, so they do not balance. So to make the charges balance, I need 2 chlorines. And this goes back to the last chapter, so I need to multiply this by 2 so that we have equal numbers of positives and negatives. This is all I'm going to have you do at this point. We'll eventually, we'll have you balance them as well. So when I say balance the equation, that means putting the coefficients in. When I say make sure you balance the formula, that means you need to make sure these charges are right and you're balancing the formula. So there is a difference there. When I say balance the formula or balance the equation, make sure you're understanding the difference between that. If not, you can always ask. Now for the next one, I've got a compound plus a compound. So I would say that this is a double replacement reaction. And sorry, this was an SR number 1 up here. So we should just label that to make sure we've got it. Now, neither of the compounds start with an H. They don't end in an OH. They don't have a .H2O. They just look like polyatomics in metals. So I would just say there's a salt plus a salt. That's what we're working with. So let's check double replacement. Salt plus a salt is number 5. Number 5, so I'm going to say DR number 5. Now, it tells me that a salt plus a salt makes a new salt plus a new salt, which isn't the most helpful. But if you remember, and if you look at this example here, the Ag and the K switch spots, right? You can see that from just kind of observing this and say, okay, well, if that's the pattern, let's just take the first elements, or the polyatomic, and switch spots. So the Mg is now going to be with CO3. The NH4 is going to be with the NO3. NH4, NO3. Now, we'll make that a little better. Now, when we rearrange them, notice that I didn't bring this 2 with. The reason there's 2 NO3s is because NO3 is a -1 charge and magnesium has a +2 charge. But the NO3 isn't with magnesium anymore, it's with NH4. NH4 has a +1 charge, NO3 still has a -1 charge, so it wouldn't make sense to bring that 2 with, because I don't need 2 of them anymore. NH4 and NO3, they bond in a 1-to-1 ratio. Same thing here. Well, the magnesium, when it combines with the carbonate, magnesium has a +2. This has a -2. So these actually balance too. So both of these, when I rearrange them, they come balanced. A lot of students like to bring with these numbers of how many there are. Do not do that. I encourage you to just strip away all those extra numbers. Don't strip away these numbers. So like NO3 stays together. That 3 stays with it, but this 2 is extra. That's like a accessory. That's how many there are. You can always strip those away and then rebuild it up, is my suggestion. We'll do 2 more here. I'll go a little bit quicker. This is just a compound. Now, the only thing it can do is break up, so it's got to be a decomposition. And if I look at my decomposition option, it's a metal carbonate, metal hydroxide, metal chlorate, acid, hydrate, oxide. So carbonate is CO3, OH, ClO3, acids, bases, all of those. It looks like it's a carbonate because it's got a CO3 on it. So that is decomp number 1. And it says it will form a metal oxide plus carbon dioxide. So I know that it's going to form a metal oxide plus carbon dioxide. Well, carbon dioxide is CO2. That's given to you. The metal oxide, well, my metal in this case is Ca. That's the only metal there. And oxide is oxygen. So I know that it's going to be CaO. And I check, calcium has a +2. Oxygen has a -2 charge. This formula is actually good to go. So these would be 2 correct formulas when I predicted the products here. And again, this is a lot of information coming together in one problem. So at first this is going to be overwhelming. You're going to have to just try a couple and then build in the pieces as you go. That's the best way to do this. Now for this last one, I see a CH compound in O2. That's combustion. And these should be the easiest problems to solve, because the products of a combustion reaction are always CO2 plus H2O. There's no balancing needed, no thinking needed. You know that if it's a combustion reaction, if it looks like it's a combustion reaction, if it's got CH and O, CO2, H2O, you're done. You just write out those formulas. We will continue to practice these, do more examples, and just keep sticking with it, because this tends to be one of the tougher things we do in all of Gen Chem. So if you're frustrated at first, that's okay, you're not alone. We will work through this together.